Hi, everyone. Thanks for joining us today. We're here to talk about Microsoft 365 networking. My name is Jeff Muleff, and I'm a program manager architect with the Microsoft 365 core team, focusing on networking and helping our enterprise customers have a better experience with our products.
Hey, my name's Paul Andrew. I'm a program manager on the Microsoft 365 core team also. I work on some of the tooling that we'll be talking about today for network connectivity.
In today's talk, we're going to cover a brief overview of our Microsoft 365 network connectivity principles, and we'll spend most of the time talking through some of the new tooling that we've been working on across the teams that Paul and I work with to help customers both understand how they're connecting to our services and how they can potentially improve that connectivity to have a better experience. And I think it's really important to understand that really the whole point of today's talk is not about all these specific tactical solutions to individual problems. This is really about helping our customers have a much better experience with our products, so they can really enjoy all the features that we work hard to deliver, and try and eliminate some of those help desk calls from users who are unhappy about the experience that they're having. So let's go into the network connectivity principles. A few years ago, when we identified that connectivity was a significant challenge for many of our customers, we spent some time thinking through what are the sort of simplest instructions or simplest concepts that we can communicate that would help people rethink their network architecture and the way they send traffic to Microsoft in order to try and make a difference. And we came up with four very simple concepts or instructions, essentially. And the four are optimizing your Microsoft 365 traffic. And that's really about understanding the different categories of traffic that exist on your network that are being used for the Microsoft 365 workloads. It's being able to identify the different types of traffic and treat that traffic appropriately so that you can, again, provide that high quality experience. The second principle is around enabling local egress, and that's getting the traffic from your end users onto the internet and then to Microsoft's network as quickly as possible. So it's really all about eliminating as much additional latency as possible and trying to minimize the path of that connectivity between the end user and the service that Microsoft is delivering. Enabling direct connectivity really refers to the concept that there are many solutions in the marketplace today that involve what we refer to as network hairpins. So taking kind of an unnatural path between the end user and the edge of Microsoft's cloud. And again, that adds latency, and latency is something that we're trying very hard to minimize in order to provide a great experience. And then the last connectivity principle is about sort of rethinking the way you apply security to your network connectivity. Historically, it's been very common to think about internet connectivity as something that's entirely untrusted, and so you want to spend a great deal of effort understanding what that network traffic looks like and protecting your organization from unknowns associated with internet traffic. And as we move into this world of connecting to services in the cloud, it's important to rethink that security stance a bit and understand that as you're able to identify traffic in a much more intelligent way, going back to the first connectivity principle, that it often makes sense to treat that more trusted traffic in a different way and not spend as much effort in terms of breaking and inspecting the traffic, as an example, for the software as a service traffic that might be associated with Microsoft 365. So those are the four, fairly simple concepts that we came up with as our network connectivity principles. And as we talk today, I think it'll become clear that many of the tools that we're working on are directly applicable to helping customers understand how they are meeting these principles or not meeting these principles today, and what improvements they can specifically make to have a better experience. And with that, I'll hand off to Paul to talk through some of the work that we've been doing in the Admin Center.
Hey, thanks, Jeff. It's great to talk back about some of those principles again. All of the tooling, of course, that we do is to help people to try and align with those principles. So let's dive in. We're going to take a look at a few of the different tools that we have here, and we'll walk through them one by one. So the first one we're going to look at is the Microsoft 365 Admin Center in network connectivity. Before we jump in and take a look at the demo, I want to zoom in a little bit and talk about what is the networking that we're talking about here. And where are we running these tests and where do they come from? So as Jeff was talking about the principles of network connectivity, he's talking about the connection that you have between your users and Microsoft's network. So you can see that in this diagram illustrated here with 3 miles of networking. Now these are conceptual miles. They're not really a mile, but the first mile that we talk about is inside of Microsoft's network. Microsoft has a pretty large global network connecting our data centers and connecting internet points of presence where you can connect into our network and have your network traffic that's destined for our data centers routed or backhauled back to wherever it needs to go. And we spend a lot of time and effort improving that and expanding it out to get closer to customers. So what we're talking about today is what we refer to as the middle mile and the last mile, sometimes known as the enterprise mile. And these are the parts of the network that you have control over or influence over, at least, in how you connect to Microsoft's network. So I want to zoom in to these particular parts of the network, and then we take Microsoft's piece, that first mile, and I've shrunk that up to the top right here. And so this allows us to take a look at just exactly what we are testing and what we are looking for, various thresholds, various issues that we can identify through this testing, and how we can give you network insights about things that can help you to better align with the network connectivity principles. So I'll call out a couple of things on this diagram. You can see that I have my on-premises network down here in the bottom left. And to connect to Microsoft, I've got that enterprise last mile, and then I've got that middle mile with the ISPs, and then connecting onto Microsoft's network. And unlike a consumer working from home, an enterprise typically has some kind of devices in a network perimeter. And this network perimeter means that the location where the user is, and therefore where that network perimeter is really important for us to identify so that we can help to measure the connectivity from the user location. You also typically have with an enterprise network an additional enterprise last mile back to a branch office. A branch office sometimes connects into a head office, and we refer to this as backhauling the network. So it lengthens the network connectivity because you've got to connect to that central stack of network perimeter devices. And then for the same reason, we will commonly set up our users, if they're in a coffee shop or traveling, to connect over a VPN or something into that head office so that they can use that network perimeter as well. Now, we recommend bypassing a lot of this as in the network connectivity principles to get the best connectivity experience for Office 365 traffic. And we do recommend that because Office 365 is a trusted destination for your users connecting. It's something that you can work with us on understanding the security and trust there without having to secure it as if it was for example, a new URL which a user at a hotel had typed in because they saw it somewhere. That's obviously an untrusted destination that you would want to run through your perimeter network and all of these devices. So we're testing for the both the existence of devices that are not bypassed and also just for the impact of them. We're looking at the impact on Exchange, the impact on SharePoint, and the impact on Teams. What is specifically happening to those services from your user's point of view because there is a long piece of network or something else that's going on that we can identify. Okay, so we run these tests. What are these tests? These tests run in the background. They run on Office 365 client applications, and they allow us to test for things that we know affect the user experience. We don't run tests that don't affect the user experience. So if there's some networking test that we could run, but we don't have a correlation with the user experience, we don't do it. We're not just trying to debug here or learn new stuff. This is specifically about helping you to identify the alignment with those network connectivity principles. We also don't collect device ID or user ID information in these tests. The tests are run to help you with your location-specific network perimeter And so we don't need the device, the specific device or the specific user for those purposes. We aggregate them back to the location where users are, and also to the tenant. So we only show you results aggregated for your users. So we do have the tenant information, your customer identifier, as part of the test results there. And then we have two types of information that we share back with you. We share a network assessment, which will tell you how much does the network that you have, that middle mile and that last mile, how much does that impact your user experience? That's our network assessment, which are various numbers that we report on. And then we also have these network insights. So where we have a test that passes a threshold, we'll share a network insight and say, hey, we found this, it's a significant impact to the user experience, and here's the likely cause where you can go and investigate there. So one thing this tells us is that the location where your users are is really important for running these tests. And where is that network perimeter? Because the network perimeter is a physical location. It's either a stack of network devices in a closet or in a person's garage or where that is. So we need to identify an approximate location for where that is in order to be able to do that. We actually have a couple of different ways that we can do that. So let's take a look at those. There's three different ways that you can identify the location where users are. Now, this is not just the network egress or the connection to the internet, because remember that connection to the internet might be back at a data center rather than the user's location. We run these tests at knowing where the user's location is. We don't need to know a precise location. So the first option there, turn on Windows Location Services. We do approximate any Windows Location Services location to a maximum accuracy of 300 meters. It's no more accurate than that. And then we aggregate that to the city where the location is identified to. So we aggregate, if you're using Windows Location Services for your office location, you'll only see office locations aggregated to the city, and then they're identified by the city name. We run these aggregations over 3 days. And we update them for you every 24 hours. One benefit of using Windows Location Services is once you turn it on and clients are sending back latitude and longitude, of course, approximated to that 300 meters, you don't have to type in your locations. We can identify the cities where your users are connecting from using that latitude and longitude. So that's very convenient. Oftentimes, we talk to enterprise customers and they have policies for not turning on Windows Location Services, which is totally fine. Other times, we talk to enterprise customers and they have multiple office locations within a single city. So in those cases, this isn't useful. And so we can't get users' location that way. The second way that we have is by using what's known as the LAN subnet information. This is the IP address range which an enterprise customer has set up. You've set up for your PCs and laptops inside of your organization. And you're going to have these IP addresses assigned within a specific subnet that you allocate for each office. These are different to the public IP addresses that you use on the internet. Normally, there's a thing called network address translation because internet IP addresses are scarce. There aren't that many left. And so you will use this LAN subnet ID scheme in order to have unique IP addresses for every machine. Now, if you put that LAN subnet ID into our system and you identify the office location where it is, we can correlate the test results that come back with the LAN subnet ID information that's provided with those test results. And then you can be in control of how those offices are named, what the addresses are. You can have multiple in a city, and you don't have to turn on Windows Location Services for that. You can also, if you have this information already, you can import these with a CSV file. and you can also export those too. Again, we aggregate the result information over 3 days, and we update it every 24 hours. So it is the same aggregation as if you were using Windows Location Services. Just on one hand, you turn on that switch, which turns on longitude and latitude at the clients. The other hand is you pre-enter your locations with their LAN subnet information. We do have a third method for identifying location, which is using the standalone tool. And I'll talk about the standalone tool in just a minute after we talk about the first two. The standalone tool means you have to have a user go to the location. So it's a little more serious than just using Office 365 clients that you've already deployed. It has a couple of additional tests because you know, we know that people running the standalone tool are really just interested in the network tests, whereas people running Office 365 clients, they're primarily interested in using Office 365, not in running networking tests. So there's a few extra tests we can run in the standalone tool because of that. A couple of downsides with it. The user has to go and sign in so that it shares the test result with your tenant. And the user has to install .NET Core, which experience shows that if you send this out to your end users, some of them will have some troubles with that. The other benefit of the standalone tool is you can get the result right away. Like, you can be there, you can run a test right now, and once the tests are run, they run in front of you, you see the results. You don't have to wait like 24 hours and come back and do stuff. So we have this comparison there of these three different methods. I'm really just trying to share that it is really important to know where your locations are. If we don't have your approximate user locations to the city, all we're really telling you is an average of your network performance over your whole organization. And that means we're averaging your best performing locations and your worst performing locations, and you're going to be, you know, somewhere in the middle there. Most organizations have some poorly performing locations. What we'd really like to do is show you where those are so that you can go and align those network connectivity principles with them. All right, so moving right along, here is what network connectivity in the admin center looks like. And this can be found under the health menu, selecting network connectivity. And here I have a little bit of demo data showing you what it looks like when you first go in. And this is a sample customer called Contoso. And this customer has a handful of Office locations, and they've been identified by Windows Location Services. And so because they're identified, we can show them on the map. And we can show these circles representing the quality of the network connectivity and the assessment that we have there for those locations, that being the color. And then the size of these circles represents the proportional number of users that you have at each of these locations as well. And so you can see at a glance there what your performance looks like. Over on the right here, we're showing the network assessment. And it's showing 56 of 100 as our assessment. That's made up of an average of an assessment for Exchange, SharePoint, and Teams. And the assessment for each of those is made up by specific measurements that relate to that workload. So you're getting back what is the networking as how it impacts the user experience for each of those workloads. You can see a history there. And if I scroll down here, we can take a look at some network insights which have been identified for this tenant. And so you can see some network insights that we've identified as you're able to take action, others that you need to research a bit further, but we found a problem and you could improve there as well. If we jump into the network insights themselves, you can see here, this is the second tab here called Insights. The insights have a flyout that you can see some detail about them. And if I zoom in there, you can see this particular network insight is about an office location in Melbourne, Australia. And it's calling out that we've identified backhauled network egress. This is showing the distance between the user and the network egress to the public internet is greater than 500 miles. And there's a link for what you can do about that. And there's some more details about what we found there so that you can dig in and take a look. So each of the network insights has a detail panel like this. And you can go and take a look at documentation so that you can learn more about it there. All right, so if we switch over onto the list of locations here in the tab here, this shows you the same locations that were on the map, but it's just in a list form that you can search and filter, and you can work with them separately here. I can go and add a location, and there's a few reasons I might want to add a location here. Remember, we talked about setting up a location without having Windows location services. So I can type in the name of the location, the street address, and then I have to call out that LAN subnet ID here. So I'll go and add that. And so maybe I'm using the 10 network for my internal LAN. Now, the 10 network is one you can't use on the public internet, so it's commonly used for LAN subnets. And so I've entered this information here, and then I can go ahead and save that back. And we can complete that location. Once I've done that, if I wait till the next day, I should start to see reports for that location show back, because we're correlating that test results back with the LAN subnet. Here is what it looks like when I drill into a specific location. So I've clicked on Redmond, Washington, United States in my tenant here. And I see a summary pane first, and the summary is showing me a different kind of map view. This map view is showing me my network perimeter, where my office location here is in Redmond, Washington. And you can see it's showing connectivity to the Exchange front-end server and the SharePoint front-end server that I'm connected to. So it's giving me a visual clue as to how big my network perimeter is and where it's connecting. And this might help me to understand whether I'm connecting to something that's too far away or whether I'm doing okay. In this case, these are both pretty close, so that looks great. I can also see a specific location assessment. This is just looking at the test results for my location. And similarly, I've got a history here showing the same thing. If you look here, this is from collected samples, which comes from Office 365 clients. If I go and click on this user submitted report link here, I can see in the same location, somebody has gone and run connectivity.office.com, and they've submitted an individual user report of their network performance here. So if I'm using connectivity.office.com as my way of getting locations, I'm sending people out to those, that's how I would see those come back. They're not aggregated, it's a single report, but you can see this user also in Redmond, Washington, and here's where they're connecting to over here in, this is Quincy in Washington over here. If I scroll down a little bit, and I'll go back to the collected samples and do that, you can see this super interesting view here showing me a comparison of my network performance in Redmond, Washington to nearby Office 365 customers. And so it says here, my network performance for this location is better than 48% of nearby customers. So, okay, I'm pretty happy with that. My network performance is up here in the 80 to 100% band, but there are customers in Redmond, Washington with poorer performance in these other bands who are doing something with their network perimeter that's causing them to have that bit worse performance. This tells me if I actually have one of the worst performances, that there are people using the same network infrastructure, the same communications infrastructure in my city who are doing better. And so I have something kind of to shoot for there, and I can do a bit better. Let's take a look at another location that I have here, which is in Auckland, New Zealand. This is in the same customer. And so this location is, here it is, Auckland, New Zealand. It's connecting to an Exchange front door over here in Australia. What I have here is, if I scroll down, I can see a comparison for my offices to my remote workers, probably people at home or in coffee shops. And you can see their network assessment and what they have for the individual workloads, and compare that to what we're seeing back from the office. So super interesting to take a look at that. I can see the details for my remote workers here. If I go into the details tab for the location, and this shows all of the specific test results that we have. So here's the collected samples using Windows location services as the location, and then my remote workers split out who are not at offices. You can see there's fewer of them than are in my offices. You can see they seem to have slightly better performance. maybe to have a network perimeter which is not impacting Exchange connectivity as much. I don't know. And as we scroll down here, we can take a look at the connectivity for SharePoint and Teams here, and you can see the measurements for them as well. So pretty interesting being able to compare your remote users from your in-office users. And we identify those looking at particular attributes on the test results to determine whether this is a connection from a home or from an office. All right, so that's a quick whirlwind through the admin center and what we have for those discovered locations and those user submitted locations. Let's move on and take a look at the second of the tools today, which is connectivity.office.com. If you go to https connectivity.office.com, this is what you see. You can run these tests anonymously. We do recommend signing in. And if you sign in, that allows you to save the test results into the tenant that you sign into and makes them available in the admin center as a user submitted report. Signing in also allows you to share the test result, and you can actually just share it with a URL to other people that you're working with on your networking. All right, so let's dive in. All you need to do is go down here and click Run Tests, and we'll start running tests. There are some tests that run in JavaScript and other tests that need a download, which is an executable download. The download requires .NET Core. You can see my screenshot is frozen, the download running the tests right there at number 436. So we run a bunch of these tests, and then those results are shown to you in real time. In fact, you'll start to see some of these icons appear on the map. And if you click on the details pane, you'll start to see the tests come in as they are run in the executable. We send them back to the web page that you're looking at right there. Once they're done, you can go to the details pane and take a look at the tests that we have run. And all of the tests that we run are shown to you in the details pane. And this looks very similar to what we shared in the admin center, right? It's the same format. You've got your test name and your result that comes up here. And the little green ticks show that you're within the threshold. The red triangle shows that something is outside of the threshold that we'd like. If you click on these, we'll actually take you to the doc page that talks to you about the test and about the threshold which you may have passed there. So lots of good information here that you can dig into. There are a couple of additional tests. I mentioned this earlier, which we run in this tool that we don't yet run inside of clients. One of which is we're evaluating your VPN. If we detect there's a VPN, and there's one detected here for me, we'll look at, is the VPN doing our recommended split tunneling? We recommend splitting out traffic for Exchange Online Optimize category, SharePoint Online Optimize, and Microsoft Teams Optimize. And you can see the results of what we've found here. In this case, we've got a green result, so we're doing the right thing for Office 365 network traffic there. There's also a couple of other tests on proxy servers and DNS that we have here that you could take a look at. If I scroll down, I see test results there for SharePoint and Microsoft Teams, and I see a connectivity test. We test connectivity to every FQDN and wildcard that are required for Office 365, and any that come up as suspect will show you a concern there that we might have. All right, the last thing I'll tell you about this tool is you can go ahead and click this share button once you're signed in. I'm signed in here as this account, and clicking the share button will allow me to copy this link, and I can use that with my network engineer or other people that I want to share these results with. In addition, it's shared back with your tenant in the admin center. All right, so that's the second tool, and now I'll hand off to Jeff to talk about informed network routing.
Great, thanks, Paul. So informed network routing is a super exciting new platform that we've actually been talking about for probably about a year and a half now, but we're actually at a point now where we can begin to talk about how real it is now that it's actually available for our customers to start using in production. So what is informed network routing? You can think about informed network routing as a platform that Microsoft is providing to enable deep integration with software-defined wide area network solutions. These are third-party solutions that manage network traffic across an organization between branch locations and central offices. And the way to think about this is that Microsoft is providing a data sharing platform that allows us to publish metrics that are specific to branch locations, the physical locations where users are actually working and connecting to our services from, where we can publish metrics specific to those branch locations, as well as the actual network circuits that come out of those branch locations to handle network traffic. And unlike some of the tests that we've described previously, where we're running synthetic activity against the service, this is actually using real Microsoft 365 traffic. So we're looking at the latency experience of Outlook connectivity to Exchange Online, or the network quality signals that the Teams client is sending, or the bandwidth and congestion signals that we can get from the SharePoint clients and usage of SharePoint within a web browser. And so we're taking those signals in near real time, aggregating them on a per branch and per circuit basis, and then providing that information back to the SD-WAN solution that you have deployed on your premises. And there's a couple ways that information can then be used by the SD-WAN solution. The most obvious is just displaying those metrics within the SD-WAN management plane. That can be used for trending over time to understand how a change might have impacted the deployment for better or for worse, or it can be used at the actual moment in time to help troubleshoot an issue and understand whether or not a problem that you're having on your network is actually impacting users or not, and give you that additional insight. The other potentially more interesting way that this can be used is for improved path selection. So typically in an SD-WAN solution, you'll see multiple paths that a given network packet can take to reach the internet or to reach Microsoft services. Examples of this could be direct egress from the branch, aligned with our recommendations that we talked about earlier, or perhaps using connectivity back to a central or a regional egress location. Due to network quality issues somewhere in that path, there might actually be a positive impact by temporarily using that backhaul path as opposed to the direct egress path. Could be an outage, could be some other less impactful issue, but something that we can still detect with this platform. So those are really the two primary benefits or ways in which this platform can be used. So as we've talked about previously, this feature is being launched in collaboration with our launch partner, Cisco. And Cisco has actually already reached general availability for their first version of this integration. The first release from Cisco supports the Exchange workload only, and they are actively working on additional integration with Teams and SharePoint. The Microsoft platform that this integration relies on is currently in public preview, and we're working hard to bring that to general availability in the coming months. But in the interim, it's certainly available for our customers to begin deploying. And from a Cisco platform perspective, given that they are now at general availability, that should give you the confidence that you need to begin those lab deployments and start looking at that build for a production deployment. We are absolutely looking at further integration partnerships in this space. We have a number of active conversations, and we've certainly received quite a bit of customer feedback around other platforms that our customers are interested in using in this space. So stay tuned. We'll have some further announcements in the near future. So let's talk a little bit about what's actually involved in getting this solution up and running. Important to call out that there are some activities that you'll need to take both within the SD-WAN platform as well as on the Microsoft side. As I mentioned, this is kind of a data sharing platform, and there's some data that Microsoft is sharing that I already described. And there's also some configuration information that's shared from the SD-WAN platform into that same data storage location that Microsoft can use to make some determination about whether or not configuration changes that have occurred in the environment may be impactful to a tenant at a given point in time, and can also help from a troubleshooting perspective if you have issues when you call into support and are looking to do some network troubleshooting. So within both platforms, there's an opt-in process where a network administrator or a tenant administrator is going to need to get involved. And then from a configuration perspective, the primary thing that we need is the egress IP prefixes. So those public IP addresses that are associated with traffic coming out of each one of the branch locations in your organization. Now let's look at what that actually looks like from the perspective of the Microsoft platform. So as you'll notice, we're actually in the same portion of the admin center that Paul was showing earlier when he went through the network insights that we show for discovered branch locations. What we're doing now is actually opting into informed network routing. So there's an option within the admin center where you can enable this SD-WAN solution integration, and we'll go through and very quickly do that. It's a very straightforward process. So the first step is really about just letting us know which SD-WAN solution you're using and where you want to store your data. As I mentioned, again, this is a data sharing platform. So what we're specifying here is the regional location around the world where we're going to manage that data interchange process between Microsoft and the solution that you've deployed. So once we've selected that, we have this opt-in where we're making an informed choice around how that data is going to be stored and managed. And then there's a permission process. Important to understand here that the SD-WAN solution is going to need some permissions to be able to access some APIs on the Microsoft side that are specific to your tenant. In order to provide these permissions, you're going to need to have one of your Microsoft 365 tenant administrators perform this action. And that's really it from the Microsoft side. As I mentioned, there's an additional process that you'll go through on the SD-WAN solution side to opt in as well, but that's really all there is to enabling this. Now, from a configuration perspective, we're back in the locations section that Paul showed earlier, where we can show individual location-specific information from an insights perspective. And if there are locations that have been automatically discovered for your tenant, they'll show here, and you can certainly use those locations as is. If you do need to add locations, you obviously have that ability. And as Paul mentioned, there's an import process where you can bring a CSV file in to populate this information. So I've gone ahead and popped open the San Diego location, and you'll see now that there's an additional checkbox showing here that specifies whether or not we're going to use informed network routing at the location. I've gone ahead and checked that. And as I mentioned, the other item that we need to provide in order to enable this feature is the egress IP or IPs that are used for traffic that egresses from this location. So in this particular case, this is a small office. We're only using a single IP address to represent all the traffic coming from this location. But that's really the primary way that we will identify traffic associated with the San Diego office and provide those metrics back to the SD-WAN solution. You can obviously add additional circuits here and larger prefixes as needed. Today, we're actually not using the LAN IP subnet IDs. However, that actually is something that we will be using to further classify traffic for informed network routing in the near future. So just as it's important for those admin center network insights to add that information wherever possible, we would also advise you to do the same for informed network routing. So this is really just the start of our journey with this platform, and we're really excited about some of the conversations that we're having with partners in this space. There's a lot of ideas going back and forth between Microsoft and our partners around how we can leverage this and use this to help drive better network experience for our customers. I think one of the really important ways to think about this is that as we think about our network connectivity principles, helping to align our customers' infrastructure to the work that Microsoft's doing to bring the edge of our service closer to end users. This is really sort of a great example of us actually taking some of the intelligence that we built into our routing plane, the way we manage traffic at Microsoft, and actually taking some of that intelligence and placing it directly on the edge of our customers' infrastructure. And really taking the edge of our services, as close as possible to customers. So with that, I'll hand it back to Paul to take us through a summary.
All right, thanks, Jeff. So let's go through just briefly what we've been talking about today. And so here are our key points. Jeff and I have worked for some time on the Microsoft 365 network connectivity principles, and so we have great guidance there. And really, the work that our teams have been doing now is to try and help you with tooling to be able to align to that guidance and to help you to be able to give your end users for Microsoft 365 applications better experience because they have better network connectivity. And so the first tool we looked at was the Microsoft 365 Admin Center and the new network connectivity pages in the Health tab there, and how you can take a look at some of those discovered locations and discovered network insights and network assessments that we have. And there, the key thing to call out is that office location or user location where the user is the key to being able to make useful changes to your network perimeter. Because when you know where the user is, then your measurements make sense from the user to the perimeter to Microsoft's network, and all of those things that are going on in those different like miles of networking. So the first of the tools that we talked about is the network connectivity in the Microsoft 365 Admin Center under the Health tab. And this is where you can see the results of locations that we've discovered. Those user locations are key to getting great network insights there. And we show that network assessment for each location. And we show network insights where you can go and get guidance directly from our help pages that talk about particular scenarios that we come across where a test has passed a threshold that we want to call out that you should do something about it. So really, really much more tactical and actionable than just the principles that we initially came out with. Like, we're going to test your network based on these where users' locations are, and we'll give you those assessments, we'll give you those insights. And then the second tool that we talked about was informed network routing, where you can dig in for deeper insights working with your SD-WAN provider. And Jeff talked about how you would set that up and how you would configure that. Jeff, what do you think about the key points? How are we doing?
I think that's a great summary. I think I'm most excited about the fact that people are going to have much better visibility to how they align with the guidance that we've been talking about for years. And this should make it much easier for our customers and the decision makers within their organization to justify change that'll ultimately improve how our users experience our service.
Yeah, actually, it's been fantastic. I've been hearing from customers who started to use these tools already that seeing the numbers and seeing the numbers change when they make a positive change on their network perimeter really helps to accelerate the work, because it is work in changing your network, right? But us being able to give that feedback is really helping. We'd love to help with this as well. We have some resources here just to leave you with at the end of the talk. We'd love to hear from you, hear how it's going. We've got some links here that you can see and you can jump into, where obviously we want to talk about the principles of network connectivity that we have, but then also we've got some links here you can take a look at for the various tools that we're working on today. All right. Hey, thanks everyone for watching today. Really appreciate your time and just best wishes with your network connectivity improvements.
And definitely come join us in the tech community and provide feedback on the tools that we've talked about today and the future work that we're going to be doing in this space. Thanks again.